The displacement x of a mass on the end of a damped spring is given by x of t is 3e to the negative t sine t for values of t greater than or equal to 0, where x is in centimetres and t is in seconds. Determine when the mass first returns to its starting position at x equals 0. If we look at the function, 3e to the negative t cannot be 0. So this will only be 0 when the sign is 0. The sign is 0 when x is 0, and the next time it is 0 is when t is equal to pi. So it's going to be t equals pi seconds. Determine an expression for the velocity of the mass. Well, we could differentiate this using the calculator, but it's easy enough to do without. It's a product, so we can say u is 3e to the negative t, v equals sine t. Remember that velocity is dx dt, so we need to differentiate. So du dt, using the chain rule, is going to be negative 3e to the negative t, and dv dt will be equal to cos t. And so the velocity here is going to be v du dt, so that's going to be negative 3e to the negative t sine t, plus u dv dt, so that's going to be plus 3e to the negative t cos t, which we might want to write as 3e to the negative t cos t minus sine t. Determine the displacement of the mass when it first changes direction. So it will change direction when v is equal to 0. So once again, 3e to the negative t cannot be 0. So for v to be 0, we must have that sine t is equal to cos t. That will make the bracket 0. And that means that tan t is equal to 1, dividing both sides by cos t. So when does that happen? It's going to happen when t is equal to pi by 4. That's the first time that sine is equal to cos. Now, if we think about it, it can only happen here and here because the sine is positive there and the cosine is negative. So it's going to happen in one of these quadrants. And the acute angle is going to be pi by 4. So that was pi by 4. And the next one would be 5 pi by 4. That's when it's down here. And then it will happen again when it's up here. So that's going to be 9 pi by 4. And so on. And it will just go up by 4 pi's on the top each time. The next one would be 13 pi by 4. So if we want the displacement when it first changes, which is at pi by 4, that is just going to be x of pi by 4. Substituting that into the expression for x, we get 3e to the negative pi by 4 sine of pi by 4. And we can just put that into the calculator. It's approximately 0.97, and the units here are centimetres. Okay, so the mass is considered to have stopped oscillating when the oscillation amplitude, A of t is 3e to the negative t, drops to 0.01 centimetres. How long does it take for the spring to stop oscillating? So we just need to solve 3e to the negative t is equal to 0.01. And of course, we can do that using our class pad. So that is just going to be a solve. So we just go action, advanced, solve, and 0.01 is equal to 3e to the negative x, and that will be 5.70, so approximately 5.7 seconds.